In this lesson, we're going to solve equations quadratic in form. Notice the phrase quadratic in form. So we're going to explain what that means in a little while. And you want to do this by factoring. In these problems, though, they're all going to be fourth degree equations. So x to the fourth. In every problem, the largest exponent will be a 4. So you'll see x to the fourth, x to the fourth, x to the fourth, and so on. Okay? All right, now, so when we talk about a quadratic equation, remember the form looks like this. So this is an example of a quadratic equation that you solved before. It looked like this. It looked like 2x squared minus 3x plus 4 equals 0. All right, so that's supposed to be squared right here. 2x squared minus 3x plus 4 equals 0. So that is a quadratic equation. Now this is not quadratic because the largest exponent is not 2. Okay, but it is quadratic in form. So you may say, what does that mean, quadratic in form? Well, that means that you could rewrite this. You could rewrite this to make it look quadratic, to make it look like ax squared plus bx plus c equals 0. Okay? And here's how we're going to do this. Okay, so you got to listen carefully. We're going to use what's called substitution. So I want you to notice that that middle term right here, that variable expression is x squared. Okay? So we're going to let u equal x squared. Okay, now I'm going to rewrite all of these variable terms using the letter u. Okay, now listen carefully. If u equals x squared, so remember, always let u be that middle variable, that middle term right here, not the constant, but just this little part here. If you let u equal x squared, now listen carefully, I'm going to rewrite this over. If I square both sides, I get u squared equal, and remember x squared, when you have a power raised to a power, you multiply exponents. So x squared times itself is x to the fourth. Y'all agree? Okay. So watch what happens. X to the fourth, I'm going to say is u squared plus 3x squared is u minus 4 equals 0. So notice I rewrote this equation, this fourth degree equation, and I wrote it such that it is quadratic in form. So I wrote it using a substitution with a different variable. So that's what I mean by solving equations which are quadratic in form. Okay? So notice this looks like this now. All right, so what we're going to do, and the directions, and the idea behind these lessons is to do this by factoring, by the way. Okay? You can do this by factoring. Okay, so now we're going to go ahead and factor this quadratic equation right here. So factor this quadratic. So I get u plus 4 times u minus 1 equals 0. So that's how you factor this. Okay? Then we're going to set each of those factors equal to 0. So I get u plus 4 equals 0, u minus 1 equals 0, right? And so I get u to be negative 4, and here I get u to be 1. All right, now be careful. Those are not your solutions to the original equation, because your original equation had what variable? Your original equation had variable x. This is u. So what you got to do now is resubstitute. So resubstitute. So u is x squared. So I get x squared equal negative 4, and then x squared equal 1. And that's where I'm at. Okay? And now, since x squared is by itself, you're going to take the square root of both sides. I'm going to go ahead and rewrite this over. So square root, square root, square root, square root. Don't forget plus and minus, though. All right? And so you get the square and the square root undo each other, so you get x is equal to plus or minus. Now you got to be careful. So remember in previous lessons, the square root of a negative 1 is defined to be I, right? That imaginary unit. So if you have, in this case, the square root of a negative 4, then that is 2i, right? So remember that square root of a negative 1, square root of 4. So square root of negative 1 is I, square root of 4 is 2. Okay? All right, so be careful when you do these. So this plus and minus, so this will be plus and minus, and the square root of a negative 4 is 2I. So there's two of your solutions. Over here, square root and square root into each other, x equal plus or minus. Now be careful, that's a positive 1. The square root of 1 is just 1, so you get plus or minus 1. No I, because you're not taking the square root of a negative number, you're taking the square root of a positive number, so just 1. So how many solutions do you have altogether? There are 4 distinct solutions. 2 here, 2 here. Okay? Now, you could leave your answer like this. You could leave your answer like this, or in Newton Algebra, they're probably going to ask you to separate these using commas. So you have to say solutions, you have to separate them, are 2I, negative 2I, 1, negative 1. Comma, and don't forget to put commas between them. Okay? And that's all that is. That is what we mean by a fourth degree polynomial, fourth degree equation that is quadratic in form. See, this is x squared, this is x to the fourth. Okay? And notice that when you rewrite it using that substitution, using a different variable, it is now quadratic. You solve this quadratic, which has the variable u, but you got to go back and resubstitute because you're solving for x. It is not difficult at all. So let's look at number 2. So here's number 2. So in number 2, we have this one. We have x to the fourth plus 10x squared plus 9 equals 0. So x to the fourth plus 10x squared plus 9 equals 0. So again, notice this fourth degree equation is quadratic in form, because if you let u equal this x squared and you square both sides, then u squared has to equal x to the fourth. And so here's your x to the fourth. So this becomes u squared, because x to the fourth is u squared, plus 10u plus 9 equals 0. So we have this quadratic equation. So notice the variables are different. Okay, that's the intent. You're eventually solving for this equation, but you're going to use this to help you. So now I'm going to solve this quadratic equation by factoring. And so I get u plus 9, u plus 1 equals 0. That's how you factor this. Then I'm going to set each factor equal to 0. That's how simple this is. So I solve each linear equation. So this becomes u equals negative 9. Here you get u equal negative 1. All right, now remember that's not your answer because your original equation had the variable x. So you have to resubstitute. So what was u? U was x squared. So replace u with x squared. So x squared equal negative 9. Over here, x squared equal negative 1. And then you solve for x. Use the square root property. Use the square root property. Use the square root property. Take the square root of both sides. Don't forget that plus or minus. And now notice both of these, you're taking the square root of a negative number, right? And remember, by definition, the square root of a negative 1 is defined to be the imaginary unit I. So, over here, I get x equals plus or minus. What's the square root of a negative 9? Square root of a negative 9 is 3i, right? And so that becomes plus or minus 3i. Over here, squares undo each other, add the square root and square root and the square root undo each other. You get x to be plus or minus, and the square root of a negative 1 is just I. So those are your 4 solutions. Those are your 4 solutions. So write them separately. Solutions are 3i, negative 3i, positive I, negative I. So those are your 4 solutions. Very simple, not difficult at all. Number 3. Number 3, let's suppose we had x to the fourth minus 20x squared plus 48 equals 0. X to the fourth minus 20x squared plus 48 equals 0. So this is quadratic in form. And so you want to do this by factoring. And so we're going to let u equal this x squared here, right? And so if I square both sides, just like we did in problem number 1, I'm going to get u squared equals x to the fourth. So I'm going to substitute x squared with u and x to the fourth with u squared. So this right here becomes u squared minus 20u plus 48 equals 0. And so notice I have this quadratic equation. So this equation is quadratic in form. This fourth degree equation is quadratic in form. I was able to rewrite this as a quadratic equation using a different variable. So I'm going to solve this quadratic equation now. And so I'm going to do this by factoring. And so when I do this by factoring, I'm going to get u minus 16 times u minus 4. So always check. Negative 16 times negative 4 is 48. The outer is negative 4u, inner is negative 16u. You get negative 20u when you add them up. So now I'm going to set each factor equal to 0. So I'm going to solve each of these linear equations. So you get u to be 16 and u to be 4. Now remember, you got to think you're not done because that's the variable u. You want to solve an equation that has what variable? X. So you have to resubstitute. What is u equal to? U is equal to x squared. So x squared equals 16, x squared equals 4. And then notice, what's the best way to solve these quadratic equations? Square root property, because there's no x term. You just see an x squared by itself. So let me go ahead and rewrite this over. Very simple. Take the square root of both sides, but don't forget, you get that plus or minus. So therefore, x equals what solutions here? Plus or minus 4. No I, because that's a positive 16. Over here, what does x equal? Plus or minus 2. So those are your 4 solutions. Your 4 solutions are positive 4, negative 4, positive 2, negative 2. All right, so that was number 3. Okay, very simple. Not difficult at all. Number 4. All right, number 4, let's suppose we had this one. We had x to the fourth plus 16x squared minus 225 equals 0. Okay? All right. So, so we have this fourth degree equation. We know it's quadratic in form because that's x squared, that's x to the fourth. And so if I use a substitution for the, if I say let u equal x squared, then u squared has to equal x to the fourth. Because remember what we said, if I square the left, I square the right. So u times itself is u squared, x squared times itself is x to the fourth. So that's where this comes from. Okay, now let's go ahead and make those substitutions. So u squared plus 16u minus 225 equals 0. Okay? All right, now let's go ahead and factor. Go ahead and factor this. And so this is not that bad because 225 is divisible by 25, right? So let's see what happens when I divide 225 by 25. So that's 9, correct? And so I want to find two numbers whose product is negative 225 and whose sum is positive 16. So notice one of those numbers has to be negative, one of those numbers has to be positive. And so 25 subtract 9 is going to be that 16. So that's the one I need, 25 and 9. So u plus 25, u minus 9. All right, and it works because the outer is a negative 9u, the inner is 25u, and you add them up, you get 16u. So now I'm going to set each of those factors equal to 0. So I got u plus 25 equals 0, u minus 9 equals 0. So you got u to be a negative 25 and u to be a positive 9. Now again, that's not your answer because your variable was x, so you have to resubstitute. What was u equal to? U is equal to x squared. So x squared equal negative 25, x squared equal positive 9. Now think about these. Now you have these quadratic equations with the variable x now. What's the best way to solve these two quadratic equations? Square root property because there's no x term. So let me go ahead and rewrite this over. So what you're going to do is take the square root of both sides. Don't forget plus or minus. Take the square root of both sides. Don't forget plus or minus. Now notice this is negative. You're taking the square root of a negative number. So you got to remember the square root of a negative 25 is a positive 5i, right? 5i. So the square and the square root undo each other. So you get x equal plus or minus 5i here. Those are two of your solutions. Over here, square and the square root undo each other. You get x to be plus or minus 3. So altogether, there are 4 solutions. 2 here, 2 here. So your solutions are 5i, negative 5i, positive 3, negative 3. All right. Now let's look at one more. Let's see. Okay, so number 5, we have x to the 4th minus 13x squared plus 36. All right, and so again, this is quadratic in form because I can rewrite this using a different letter, a different variable, but in a quadratic equation. So this is not quadratic because of the 4, but it is quadratic in form. So I'm going to let u equal x squared. So if u equals x squared, then it means u squared has to equal x to the 4th. If you square both sides, you get u squared equal x to the 4th. So substituting now, I get u squared minus 13u plus 36 equals 0. And then factoring, I get, that's going to be u minus 9 and u minus 4 equals 0. And always check, negative 9 times 4 is positive 36. The outer's negative 4u, the inner's negative 9u, and you get negative 13u. Setting each of those factors equal to 0, I get 2 linear equations, so those are easy to solve for u. When I solve for u, I get u equals 9. Over here, I get u equals 4. Okay, now remember though, I'm solving the 4th degree equation here, which has variable x. This is variable u, so I got to resubstitute now. So x squared equal 9, x squared equal 4. The best way to solve this quadratic equation, since there's no x term, all there is an x squared term and then the constant, you're going to take the square root of both sides. And when I take the square root of both sides, plus or minus, take the square root of both sides, plus or minus, I'm taking the square root of a positive number in both cases, so I'm not going to use that imaginary unit I. So here, the square and the square root undo each other, so you get x equal plus or minus 3. Here, you get x equal plus or minus 2. So those are your 4 solutions. If you write them separately using commas, your solutions are 3, negative 3, 2, negative 2. Okay? All right, now just to show you, all of these, this is going to be number 6. All of the problems we just did, the coefficient of x to the 4th was a 1 in every problem. If you go back to problems 1, 2, 3, 4, and number 5, the coefficient was a 1. All right, so it made this whole situations kind of easy to deal with. It wasn't difficult. But let's look at number 6. We're going to do one where the coefficient of x to the 4th is not a 1. But the process is the same. The process is the same. So let's look at number 6. So number 6, let's suppose we had 4x to the 4th plus 27x squared minus 81 equals 0. Okay? So I have this 4th degree equation. The difference between this one and all the others is this coefficient right here. This coefficient is not a 1, it's a 4. Process is the same. Okay? So let's go ahead and do that substitution. So we're going to let u equal x squared. So if u is x squared, then it means u squared is x to the 4th. So now substituting, I get 4u squared, because x to the 4th is u squared, so 4u squared, plus 27u minus 81 equals 0. So this 4th degree equation is quadratic in form. So I'm gonna solve this quadratic equation by factoring. And to factor this one, you're going to factor it as 4u minus 9u plus 9. That's how this is factorable. And just always check yourself. So the first outer and the last, u 4u times u is 4u squared. The last, to get the last, the negative 9 times positive 9 is negative 81. The outer is 36u. The inner is a negative 9u, and you get 27u. So this is factored correctly. Now we're going to set each factor equal to 0. Just, oops, u plus 9 equals 0. Just like in the previous problem. See, no difference except this time it's the coefficient of x to the fourth is not 1. And so when I solve these linear equations, I get 4u equal 9. U equals 9 fourths, right? Over here, u equals negative 9. Okay. Don't forget, just like in all the other problems, you're solving for the original fourth degree equation, which had variable x. This is variable u. Those are solutions to this quadratic equation right here. Okay? So you have to now find out, well, what's the solutions to the original? So you got to resubstitute. So x squared equal 9 fourths, x squared equal negative 9. And now you're going to solve for x. So you're going to take I'm going to rewrite this over. You're going to take the square root of both sides, just like this. Don't forget plus and minus. You're going to take the square root of both sides, plus and minus, okay? The square and the square root undo each other, so you get x equal plus and minus. The square root of a 9 is 3. The square root of 4 is 2. So you get 3 halves, plus and minus 3 halves. Over here, x equal plus and minus the square root of a negative 9. Remember, you're taking the square root of a negative number, so don't forget an imaginary unit I, but that's 3i. And that's it. So it's the same idea, except that this coefficient is not 1. So the factoring is a little bit more challenging, but not difficult. And so your solution, there are 4 solutions. Your solutions are 3 halves, negative 3 halves, 3i, negative 3i. Okay? So that is, let me get the original. So that is solving equations quadratic in form. Solving equations quadratic in form. And in our problems, we were solving fourth degree equations. And so we used a u substitution in every case. Okay? All right, so that is the end of this lesson.